会場の皆様、ホートンワークスインターナショナルマーケティングバイスプレジデントジョン・クライジャ様を大きな拍手でお迎えください。
Ladies and gentlemen, please welcome to the stage John Kreisa, VP International Marketing, Hortonworks.
Konnichiwa and Yokoso Hadoop Summit. We're very excited for you to come here today. We're very excited to have Hadoop Summit. My name is John Kreisa. I am the Vice President of International Marketing for Hortonworks. And as the host, along with Recruit Technologies, we're very excited to welcome you to the first Hadoop Summit in Tokyo. And I'm very excited to announce that this is a sold-out event. So a fantastic response, a fantastic interest around this technology, around transforming businesses, and I think you'll really enjoy the next day and a half of information. Now, today's keynotes will all be in English, so if you are English speaker, can understand English, you won't need the headphones. But if you would like to help with translation, of course, we have translation through the headphones. So again, thank you very much for coming today. We could not put this conference on without the help of our sponsors. And our sponsors help us present the event, they present content for the event, and they also help us be able to put on all of this information and help share this with you. So I would like to just give a warm thank you to all of our sponsors for sponsoring today. So first, we do want to encourage you to share the information, and I realize that there might be an issue with the Wi-Fi right now, and let me assure you we have the best technical experts working on it right now to make sure that the Wi-Fi works for you. But please do share the information. It's an open community, it's open source, and we promote the sharing of information. And you can see the hashtag for the conference there at the bottom. It's HS16 Tokyo. And in other places where we've had this conference, we've actually been able to make that a trending Twitter hashtag. So I'd like to encourage you to try to share as much as you can using social media on Facebook or Twitter so that you can help us promote this and get the word out there and make sure everybody knows that the conference is going on and that we're sharing information. Let me give you a little bit of information just about Hadoop Summits. This is the 4th Hadoop Summit that we've run globally this year. It's the first time in Tokyo. And it is a growing community. And by attending today, you are all part of that growing global community. Now, more than 6,500 attendees have attended a Hadoop Summit worldwide. A tremendous community coming together, sharing information, sharing ideas, learning about how data is transforming their businesses, and learning about how they progress on their journey with Hadoop. So it's a tremendous conference. You are now part of that global conference, and we thank you very much for participating. Hadoop Summits are an event for the community, by the community. So many of the sessions that you'll hear over the next day and a half are given by community members, engineers who are working on the software, partners who have solutions that plug in and enhance the technology, and end users who are using the technology. And in fact, what we like to say is this is a conference that appeals to the hoodies, the technology people, and to the suits, the people in business who want to learn how it's transforming their business. So it's a conference that appeals to both sides of the user community. Now let's talk about this specific conference, the Hadoop Summit here in Tokyo. We had more than 205 sessions submitted in our call for papers. A tremendous response. Lots of organizations, 87 companies wanted to share their information with you, the users, you, the attendees. We have 48 sessions scheduled over the next day and a half. So regardless of the kind of information you want to learn about, if it's deeply technical or about how the information is transforming businesses, about how different technologies plug into it, there are different sessions for you. And in addition, there's 11 different business sessions from companies who are using the technology where they can share their experience. And in fact, today on the main stage, we'll hear from some of those companies and how they're using the technology to transform their business. Now, this is spread across 5 different tracks. All of that information is available on where the sessions are in your program guide. A brief word about Hortonworks and our presence here in the Asia-Pacific region. We have offices across the Asia-Pacific region helping organizations to transform their business, to implement the technology, to really guide them on their journey with Hadoop. We have offices here in Tokyo, in Seoul, in Australia, in Singapore, and in India. So regardless of where you are or where you're implementing the technology, Hortonworks is the company that can help you be successful along that journey. So what I'd like to do now is bring up our very first keynote speaker for the day. I'm very excited and pleased to be introducing you to and bring up on stage Sean Connolly, our Chief Strategy Officer from Hortonworks. Sean?
Thanks, John. Thank you. It's exciting to be here in Tokyo. I started my journey at Hortonworks a little over 5 years ago, and I've been to many Hadoop summits in the US, in Europe, and now here in Asia-Pac. So I'm very excited to be spending the next couple of days with all of you. I'm going to spend the next 18 to 20 minutes really sharing our thoughts and some stories, both from an architecture as well as a transformational perspective, on how data is fundamentally transforming every industry. So over the past 5 years, there's been much written about the growth of data, into the zettabytes of data. But industry analyst numbers really show that about 64% of enterprises are investing in big data in some form or another. 31% of those enterprises expect to be managing about a petabyte or more of data. However, with that said, particularly with a lot of streaming data, real-time data, as well as data you need to store, 88% of that data is still not under management. Now, this isn't about capturing all the data. This is about, if you capture the data, how do you drive value out of that data? So it isn't just capturing data for data's sake. It's how do you actually transform that into value? So this 88% of data not yet under management is, how do you bring that data together in a way that can help you drive some business value and engage your customers more directly? With that, over the past 5 years and over the recent years, the rise of the hyper-connected world that we live in is just increasingly being prevalent, right? We just live in it every day, where the Internet of Things is spawning new forms of data everywhere. There are sensors literally on everything, besides the mobile phones, et cetera. And so there's 1.1 billion data points generated just by sensors daily. So there's a lot of new forms of data that are out there that you can begin to figure out how you capture that value. 2.5 billion gigabytes of data generated worldwide daily, and more than 2 exabytes of data every day. So the Internet of Things in this connected world is effectively doubling our data every 2 years, so it's an exponential increase. And like I said, much has been written on that, in the press, et cetera, over the past few years. Now, my point at the beginning was that virtually every industry and every company in every industry will be impacted by data. And it's a must to be able to harness the data and drive value out of that data. Progressive Insurance is an example of a automotive insurer in the US that has devices in the cars, and they drive usage-based insurance, optimizing the rates down to the individual. And so far, they've collected over 10 billion miles of driving data in order to do that analysis and to augment their existing systems where they would calculate the insurance rates and insurance premiums. WebTrends is an analytics company that is dealing with 13 billion events daily through their infrastructure. Symantec is in the security business, and their solutions engage 75 million users, 120 million plus devices that are connected. and 57 million attack sensors across 157 countries globally. So this is a big data problem with data in their data center, data that's out there at the edge, and data that's flowing through the cloud. Us as individuals, healthcare is being fundamentally changed. And so we have hospitals that are doing genetic research, right, to deliver better healthcare. So hospitals like Mercy, Arizona State University, and others, 20 billion rows of data just when they're doing their genetic research. So a lot of value in that data that they can harvest. But with it, I think we need to set the context that up until recent years, the traditional data technologies had constraints, right? For the most part, the existing systems were created for a structured world of data. Data in mainframes, data in relational databases, data in rows and columns. So it was very difficult to actually capture these new forms of data that really aren't rows and columns. Those applications and those databases tend to be very siloed. Not everybody had access to them. They were typically tied to a single application. So the insights that you could derive from that data typically were rear view mirror, a week old, a month old, outdated, right? So you weren't really driving your business. You were reporting on what happened, not what's going to happen. Now, the business implications of that is really you aren't able to get a single view of your customers, your products, your supply chains, or if you're in healthcare, a single view of patient, right? And so it's very limited in its usefulness to the business. And then the impact on IT was how do you change from a single application-centric view to bringing data across applications in one place. The traditional IT has been mostly about capturing data that's already in the data center, and it's not really for this world of cloud and sensors and things that are outside the traditional data center. So if we look at the picture today, we have mainframe data, relational database data. That's been the realm of the architectures up until the past few years. But we have these megatrends that have really been borne up over the past few years around cloud computing, Internet of Things, of course, and big data and analytics. And so, that dynamic requires what we call a connected data architecture that can operate at the convergence of those megatrends, right? So how do you get a data architecture that embraces cloud computing as well as data center computing? How do you get a data architecture that can enable you to manage data that's born in the Internet of Things? And then how do you get a strategy around big data and analytics, both for real-time streaming data as well as decades of historical data? How do you get your hands around that? And so we refer to that as a connected data architecture. And the use cases that this type of connected data architecture can unlock are very transformational across different industries, whether it's predictive retail, factory automation, connected car. And I'll cover connected car in a little bit to really give you an example of what this architecture looks like in that ecosystem, as well as other types of modern applications built on data. Fundamentally, we believe that data is the new currency for business, right? It's inherently, you can tap into its value and unlock new value streams from individual data sets. So if we look at a simpler view of the connected data architecture, it's about enabling this new generation of modern data applications that span the cloud and the data center, and that are about tapping into the value of all data in motion as it's real-time streaming before you even stored it anywhere, and data at rest for a large swath of history, if you will. So let's talk specifically. We'll use connected car, and I'll actually use the energy sector as two examples of how this is transforming industries. So connected data is driving the connected car industry, and it's not just about the automakers, right? So you have automakers like Toyota, Mitsubishi, Daimler, Ford, and others who have connected car initiatives that are going on, and it's transforming how the automakers do business. But the connected car is transforming many industries. The progressive insurance is one example. So the insurance companies are transforming. Government agencies increasingly are rolling out sensors in connected cities and connected infrastructure that the automobiles will interact with, right? And I'll cover some examples of the use cases of connected city and automobiles that can be unlocked when you treat these sort of holistically. So here's my connected data architecture, sort of reference architecture, if you will, for the connected car scenario. And I projected some of the use cases into this diagram. So in the upper left, we have the car and sensors in the car and control systems in the car and infotainment systems that provide the user experience for those driving the car. You want to get that data and maybe blend it with connected city and connected infrastructure data in the cloud. It's real-time streaming. You want to do analytics on that data, and then you may want to land it in the cloud so you could do some machine learning on that data to do time-based route optimization, enhance traffic patterns or what have you based off of that top-level cloud set of use cases. But there may be exceptions that are happening in the cars, operational issues that are happening in the cars, and you want to bring those exceptions down into the data center. And so on the lower right, we have manufacturing line data from the manufacturing of the cars, and you want to bring that into a central data at rest platform where you could do a 360-degree view analysis of the operational data from the cars and the manufacturing line data. So maybe you might be able to do root cause analysis on issues you're seeing in the field that maybe have been caused by manufacturing issues. So this is the type of applications that can be unlocked in a connected data architecture. Being able to act on data as soon as it's born and when it's in motion, and then bringing that data all in one place so you can do more historical analysis on that data as well. It's not just the realm of connected cars that are impacted. Like I said, every industry is impacted. So the energy sector has its range of transformation that's happening. From smart grid technologies, smart meters that are in the homes, basically sensors across the grid that enable the optimization of energy delivery. So we're seeing decades and sometimes centuries old utility companies transforming their relationships with their customers based off of smart meters and smart grid technologies that enable them to deliver energy more efficiently and enable their customers to use that energy and spend money more wisely. So there's a similar connected data architecture that for the energy sector, where you have the sensors and control systems, right? You have other connected devices, and you have time series analysis that you might do on those data streams. On the bottom, the type of use cases, particularly for exception-based monitoring, might be around equipment failure and proactive management and engagement of the devices that are in the field, so you can replace faulty equipment before it fails, as an example. So again, these are just some illustrative examples in these sectors that impact more than just the energy companies, their holistic value chains that can derive value out of the data. So there's a shift to a connected data architecture, in summary, that's happening today. We're seeing these use cases that are within the data center and outside the data center that are leveraging all data. Data in motion from the point of inception of when data is born all the way through its life cycle of data. Data at rest platforms, I think our conference today is the Hadoop Summit. Hadoop plays a key role in storing that data, but you're going to learn about other technologies like Apache NiFi for managing data in motion, and technologies like Kafka and Storm and Spark and others that enable you to get value out of that data. We live in an exciting time where there's just a lot of open source innovation. I think the challenge for enterprises is how do you bring it to bear to actually solve business needs and unlock new revenue streams. The goal is to be in a position to derive value out of that data. We call that actionable intelligence, to make smart applications, intelligent applications. At times, sort of a feedback loop, if you will, of real-time data influencing your model and updating your model so it's adapting to the changes that are happening in this new connected world. So the future of data, as we see it, is about harnessing all of that data and bringing it into one sort of under management, right? So you can actually derive value out of the data. So I covered the connected car ecosystem, insurance providers, automakers. I covered the energy example, where it's not only the providers, it's the distributors, as well as the actual homes and businesses that leverage the energy. But this transformation is happening across all industries. At Hortonworks, we're extending our business, and John Kreisa is helping to lead the charge of our team from an international perspective on serving Asia as well as Europe as part of his charter. In the US, we see widespread adoption across the financial services sector, banking, mortgage industries, et cetera, insurers and those types. The retail industry has been really undergoing fundamental change. It's not just about how you interact with your customers, but increasingly the retail use cases are, once they're able to assemble a single view, how do you leverage that to optimize your supply chain so the distribution of your products is highly optimized, right? And we're seeing a lot of that supply chain industry being transformed by the availability of real-time data and location data. The telecommunications industry, very popular as well. So I'm going to close out my opening session by really just encouraging you, as you spend your time over the next day and a half, to learn about the technologies, but think about those technologies from the future, from imagining the future where business has access to all data, right? Where the goal here isn't to do historical reports on the data, it's actually leverage that data so you can actually shape your relationship with your customers before they've even transacted with your business, right? So be real time and at times predictive in your engagement models. That's going to require bringing under management data at as close to the edge as possible and interacting with that data in real time and doing a level of analytics around that data. It'll unlock new customer engagement models in healthcare. It's new patient engagement models, right? So it isn't just about the customer. It can be about the product, the patient, the supply chain, or what have you. In some industries, the geolocation point, the GPS location, is the new single view pivot point, right? So it isn't just about the customer as the center. It's about the location of items. And that's something I think that's systemic from our connected world, right? Creating new sources of revenue. We're seeing in the US, for instance, John Deere is a tractor and combine manufacturer. Many would think they're in the heavy equipment business for farmers. They are not. They're in the analytics business. Those tractors have 36 sensors on them that collect information, and they provide analytics back to the farmers to help them maximize crop yields, to help them optimize the turning radiuses of the combines so they use the least amount of fuel possible. They fundamentally are transforming the way they think about their business. Data is everyone's product. So I think inherently in businesses today, the goal is how do you encourage collaboration and an open approach to sharing data without losing the security and governance that's required to run your business. You don't want to open up risk, but the more people that can interact with data and think creatively around that data, you'll more quickly accelerate the innovation of your business and your competitive advantage. So with that, that's how we at Hortonworks think about the future of data. I wish you well during the next day and a half. Take advantage of the experts presenting, and I look forward to hearing new stories here at Hadoop Summit. So thank you for your time. Thank you, John. Yep.
Thanks very much. Thanks very much, Sean. So Sean gave us some great examples of how data is transforming companies across the globe, some examples in the US, how they're using this technology to really fundamentally change the way that they're going about their business. So hopefully that gave you some things to think about. What I'd like to do now is shift and hear about a local company's journey, a local organization's journey with Hadoop. And I think that'll give you some additional insight into how you might progress with your journey with this particular technology. So I'd like to bring up Nobu Ishikawa from Recruit Technologies. Thank you.
Okay. Thank you for introduction. Good afternoon, everyone. My name is Nobuyuki Ishikawa. I'm a manager of the Big Data Product Development Group for Recruit Technologies. Today, I am much honored to speak about Hadoop's impact on data analysis management, as well as information application within the Recruit Group company. Please join me to reflect on how Hadoop is changing the way we work with data. The details will be delivered at the Recruit Technologies session. Feel free to join if you are interested. Okay. First, please allow me to introduce the business model of Recruit Group company. The main business model for Recruit is built on matching between client and customers. Our clients are enterprises to deploy information, and our customers are who are searching for information. In other words, we provide mediums in web and smartphone matching information that enterprises are deploying and one that users are searching. Okay. The second thing, I'd like to introduce the business domain. There are various domains used in information matching businesses. Well, we have many big events and big decisions to make in life. For example, going to college, buying house, marriage, we have life event domains for this. Talking about travel, health and beauty care, or other daily consumer expenses, we have lifestyle domains. So what they provide is information services that support choices. Okay. Thirdly, let me explain about the Recruit company structure. You are looking at the block diagram. As I mentioned before, the main business services in Japan has been operated under the control of the Media and Solution SBU. Our Big Data Solution division belongs to Recruit Technologies company, which does cross-functional businesses. Besides Big Data Solutions, which I will continue to talk about, Recruit Technologies plays a role in providing IT solutions transversely in terms of infrastructure, environment, and security as well. Now, moving on the main part. I'd like to talk about the history of Hadoop uses in Recruit company. In 2009, Recruit Group started examining the utility of data application generated from various domains in-house. 1 year later, in 2010, the use of Hadoop was decided as a data utilized infrastructure. Then data application began being conducted in scale inside the group company. In 2030, use of Hadoop advanced in a variety of business and again was performed to optimize the Hadoop environment within the Recruit group. Looking back now, in Recruit, Hadoop is recognized not only as an infrastructure, but as an ecosystem of data analysis tool. Since then, the use of Hadoop keeps proceeding with online processing, full-scale adoption of HBase. Data usage recorded in 2050 is more than 1 petabyte. Now, new data utilization using the ecosystem, such as Spark, has been realized. Then, the amount of data that we store at Hadoop looks like this. You can see the needs of data analysis is growing rapidly every year. However, what I'm showing here is only one part of all this data in Recruit Group. We believe that it is important to increase the type of data that can be handled in order to connect vision and algorithm for the future. For years to come, the number of both small and big cases applied by different uses of data on the Hadoop platform will be more than 200. For example, as I mentioned at the beginning, optimization of matching logic in Recruit companies' core businesses and user experience improvement, such as search and content recommendation, and also Recruit site in terms of cross-use referrals. As I explained before, Recruit Group is deploying matching logic in many services. We are improving the accuracy of data analysis performance. For example, you are looking at the article published in June 2016. The article is about a service named CAST, conducted by Recruit Agent, a job-seeking service company, which applies data analysis to give recommendation. The data stored by Hadoop includes both applicants' browsing, applying history, and data of what kind of talents who have passed document screening round. In fact, even the stock value goes rising or not after this article. I myself think that this case is one of the great inspiring stories about performing data analysis. Don't you think so too, Mr. Damian? Yes. Thank you for your reaction. Let me explain another case of Hadoop. It's used in data scoring. Besides other businesses that I have mentioned before, Recruit company is also doing business on publishing media. Regarding to marriage, we have Zexi, an application using Hadoop to personalize content. Understanding the taste of customer based on browsing history of searching for wedding ceremony. All the data of faces that customers have experienced will be added up and stored by Hadoop. About faces, for example, after propose, looking for ceremony hall, and so on. In addition, Hadoop is also used in improving users' UX by optimization search result. Based on the future data of area, station, job type, user segment, and priority is scored by Hadoop and indexed by Sora. Regarding to user segment, on the other hand, it can be updated in real time by the user viewing. Users can use the same Recruit ID in most of Recruit services. Based on stored data, customer can make best decisions. In this backend data management, Hortonworks data platform is used. Moreover, using the great volume of data, we are implementing cross-use referrals in our services. For example, after using Jalan service to book a hotel, items sold in Pompare Mall site, which is an easy site, will be recommended. By developing infrastructure, Hadoop and HBase, recommendation introduction becomes simple and low cost. We can proudly say that Hadoop is a key technology in Recruit company. The details about the utility and operation of Hadoop environment will be delivered in our separate session later. Please come in. After the boom of Hadoop initial introduction, they are considering other middleware for the infrastructure system of data analysis. It is the use of cloud-based alternative to on-premise or appliance products for the enterprise, and a tool to connect to Hadoop, such as a BI tool. Also, Hadoop plays an important role in data analysis. It is obvious that we are continuing evolving through the use of the ecosystem. What I am trying to say here is that Recruit company is always open to new idea for faster promotion and efficiency of data utilization. In addition, that HDFS, data storage flexibility, features of ability, and schema on read, that can be stored as a raw data, has become a key concept in Recruit company. As a result, we can collect all kinds of data in terms of unstructured data, then effectively make use of it. This viewpoint leads to the result that Recruit can work various types of data. In recent years, we have started to store all kinds of data. The kinds of data vary from simple things like PV and transaction data of web services to unstructured data of unique media information, such as image, text, videos, and so on. Or even more indoor location data can be obtained in offline events, and operational data is generated by such as sales activities and internal operation. Of course, not only storing data, you need to consider measured connection and utility policy together. This is a famous ribbon diagram that represents matching model of Recruit. The left side represents customers. The right one represents clients. What we do is collect the information from both sides. In Recruit, it was focused on the customer side with many policy using a recommendation system. However, when both volume and variety of data increase, it begins data applications in different domains. For example, automation of sales support, reviewer businesses, and so on. If you take an overview on usage of these new areas, you can see some great features. In other words, data utility solutions has replaced labor work. In Recruit, we are now creating the environment where people focus on creative work, while the left simple one can be done by machines. Recruit has S3RT called ART, which provides solutions such as using unstructured data and work alternatives. ART is able to simply feedback knowledge to all clients with lower cost by providing API. Then, the implementation of deep learning or other deep net algorithm in getting easier. Not only limited to customer side, data utility is supposed to be promoted in dealing with client side sales creation work. Regarding to this topic, you can come to my session later. The details of the stories that I have talked will be delivered in 3 following sessions. Feel free to join if you are interested. Last but not least, as you can see, Hadoop can become more and more active in our work. By storing large volume of data, Recruit can trigger data analysis promotion. Moreover, it can provide operation means to data scientists. Then, can come up to variable contribution to data utilization solution. In the future, Recruit Group company will continue working with data along with evolution of Hadoop. Last, it is the most important story in my presentation. Talking about my hobby. I like raising beetles and saltwater fish. They are my 2 darling. Then, thanks to Hadoop, I fell in my 3rd lab. It's elephant. Thank you for listening.
Thank you. All right. Thank you, Shikaba-san. So we heard about a 6-year journey that Recruit has gone with Hadoop and how it's really fundamentally changed their business and the way that they can help both their clients and the customers. So pretty fantastic journey. I would like to continue along the theme of hearing about how customers and companies are transforming their businesses. So what I'd like to do now is welcome 2 panelists up on the stage with me, and we'll have a little bit of a Q&A about how they've transformed their business. So let me start with Damien Contreras from Coca-Cola Japan East. Damien? Thank you. That's your seat, yes. And Eric Spitzer from Daimler. Please join me, thank you. Oh, we get some walk-up music for you. Very good. Okay. Damien, let me start with you. Can you just describe your role, please?
Yeah, so I think you know our brand. I'm pretty sure that you had already one of our products, maybe during the lunch. So I work for Coca-Cola East Japan. What are we doing at Coca-Cola East Japan? Basically, we produce and we distribute the brand you love, which comes, it can be coffee, it can be Fanta, it can be carbonated, it can be many different products. Actually, we have more than 50 different products in Japan in terms of lineup. Coca-Cola East Japan is a very young company. I know that you think that Coca-Cola is very old company, but Coca-Cola East Japan as a company is very young. It's the merger of 5 different companies into a single one, which happened 3 years ago. And as you can expect, we inherited basically 5 different information systems, which were built on top of the mainframe system. So basically, we have 10 different systems which are just piling on each other. And we have one more layer which is specific for CCJ. So we have lots of challenges around data, around integration, and my job is basically to try to put some sense around all that mismatch of data and systems, try to harmonize and standardize the way we operate. And as well, that's why I led the big data and the implementation of Hadoop from end to end, from the POC to the implementation in CCJ.
Very good. Thank you. Eric, can you do the same?
Yes, so good evening. My name is Eric. I'm here for Mitsubishi Fuso. So you may be a little bit confused why a Daimler logo is on top of me, because Mitsubishi Fuso is part of Daimler Trucks Asia, and this is part of Daimler Trucks. As Daimler Trucks, we are the biggest commercial vehicle producer in the world. But as I said, today I'm here for Mitsubishi Fuso. I think you all know Mitsubishi Fuso. Unfortunately, I was not able to bring a truck with me on the stage, so...
Mine is smaller.
My responsibilities, I'm the manager of the process design and innovation team, which is also related to IoT and cloud. And in this regards, I'm responsible currently, we are building in Daimler Trucks Asia currently a common data platform. And this is why I'm currently here. And I'd like to present this use case a little bit to you.
Well, that's very good. So let's stick with you, Eric. And in terms of the first use case that you had, how did you start your journey with Hadoop?
So basically, our use cases start with a simple problem. Our trucks have unnecessary downtimes. So let me explain this a little bit. We're talking about commercial vehicle owners. So they are utilizing their trucks to make money. So every downtime of the truck owner can't use his truck, they're losing money. It only costs money. It's a big problem for our truck owners, and so it's also a big problem for us. So we tried to solve this problem. So one of the first steps we did, we were collecting live data from our trucks. So basically, it's what's commonly known as telematics. We have some devices in our trucks sending all these sensor data into our platform. These data as such are not very useful. So the next step we were thinking about, we have all kind of data already existing. They are in this typical silos. We have engineering data from our assembly line, from our warranty systems, sales systems. We have all kind of history data. So the next step was bringing it in the same data lake, on the same single source of truth. As soon as we have all these data, we could go actually from a more reactive to a proactive model. So without, not only, for example, if there's a problem on the truck, currently we are just reacting to this problem. We're trying to understand what was this problem and trying to solve it. Now with all these data in place in our data lake, we want to actually predict. Before a fault is happening, before there's a problem, we're trying to avoid this problem. And this is what we're currently building.
So combining a large number of pieces of data together to be more proactive and predictive with regards to the maintenance of the trucks. And we'll come back to that use case as well. So Damien, why don't you give us a little bit of your insight?
So we started our Hadoop journey by drafting a strategy in CCJ. We sit down with my CIO and we define basically what we wanted to improve and where we wanted to what kind of capabilities we wanted to develop. And one of them was basically Hadoop. One of them was as well to improve the diversity of the data inside CCJ as well, because it was very much siloed. and as well standardize the communication between systems, because we have point-to-point communication in most cases. And as well, we thought that we could do better with the data that we had at hand and do more analytics stuff. So that's basically the first use case that we addressed is the analytics part. And we have one operation which is very important for CCEJ, which is the replenishment of vending machines. You know that you have lots of vending machines in Japan. We are managing about 550,000 vending machines ourselves, which means that basically you have vending machines at every corner. It can be on the top of the Mount Fuji. It can be, you know, in offices, and you have really a wide variety of environments. So as you can understand, the velocity of sales really depends on that environment. Of course, a vending machine which is inside an office is not behaving in the same way as one which is outside and where you have a matsuri, you know, happening on Sunday, because you will have a peak of sales for that one, whereas the one in the office is basically flat. You buy your coffee every morning, then your consumption is basically flat, right? So what we thought is basically that we could leverage external data as well as internal data and try to come up with a better model than what we had. And I'm proud to say that right now, all the vending machines that we are managing in CCJ are actually you know, managed through Spark and with the program which is running every night. Just to do that, to know exactly what would be the consumption inside the vending machines for the next 2 days, basically.
So in the ideal case, as we were talking earlier, your trucks would go out full with exactly the right amount of product, go and replenish it just when they need to get replenished in those machines and come back. So more than half a million vending machines being managed, as you said, with Spark. Pretty funny.
Yeah, exactly.
Good. Do you know if they're using Daimler trucks? Do you know?
No.
I'm kidding. I don't know. I'm kidding.
So I'm not totally sure.
I'm kidding. Let's just talk a little bit about the transformation. So, Eric, when we were talking earlier, you know, and can you just sort of give some insight in terms of how you see this sort of transforming the things that you can do there for Daimler in terms of the services and business?
So I basically see three big topics we could solve with that. First is data-driven engineering. So basically, it's already kind of a data-driven engineering what we're doing. So we get a lot of testing data from our test vehicles, our reliability trucks. They're completely connected, so we're getting all these data. But it's only during testing periods. Now we're getting our engineers getting on a constant base from every truck all the information they need and could directly use it to improve our product. The other thing is more like, we always call it like indirect feedback. So just by how are our customers actually using our trucks, we're getting very good feedback how to improve our product. It also like, not every truck driver is the same. Every truck driver, like for example, trucks are operating in different kind of environments. For example, if a truck is driving in Hokkaido, it's totally different than, for example, it's driving in Okinawa. So the weather conditions are completely different. So for example, also specific maintenance concept for us has to be different because specific parts are tending to fail under specific weather conditions. So this is the second part what we could do. And the third part is then more on the part of digital services. As soon as we have all these data, analyzing these data and going more to an interactive model, we could give our customers new services to increasing their business, to increasing the utilization rate of their trucks, to optimize their own business.
Right. So several different areas where you're able to transform the business in terms of understanding the utilization of those vehicles, plus create value-based services on top of that, using that data and analyzing that data.
Yes.
Yeah, no, that's very interesting. Similarly, would you say it's transforming the way that CCJ is you know, providing services and running the business?
Definitely, as I explained, you know, for the truck and the replenishment, that's one good example where basically the fact that we have Hadoop could transform the operation and make it better. The other thing is now that as I explained, we have many data sources and many silos of data. And frankly, those solutions, lots of solutions that we have internally have not necessarily been built internally and left to vendors, which have built something which is very nice, but doesn't really play well with the rest of the environment. So they have their own set of data, their own master data. They are very siloed, as you explained. The fact that we have this Hadoop project and that we are now migrating all those data into a single instance make us aware of where we have data, what kind of data we have. It's also a way to start working on metadata and understanding the business meaning of the data, and to stage that data into a single entry and single system, like a data hub, where we aggregate all those data and we know what is the accurate data, where it's coming from. We have the most granular data, for instance, for sales only inside Hadoop. We don't have it anywhere else. We can enrich that data and make sure that the data that we provide for one report is exactly based on the same data as for another one, or for the logistic department is the same as the sales department. It was not the case before. Each department basically had their own set of data and were coming up with different ways to show how they use that data. So they had different aggregation, different meaning for that data, etc. I think Hadoop is and as well the BI tools that we put behind, is the enabling that we have one system which is just showing different dimension but based on the same data.
Right. So you're overcoming the silos of the different systems.
Yes.
It doesn't mean that those systems aren't needed or necessary for their specific function that they're doing. It's just that you get additional value by combining that and overcoming some of those silos. So we didn't necessarily talk about this much, but those are existing silos. There's existing systems that you're using. So would you say Hadoop complements the things that you have that are using in place today by and large? It might replace some things, but by and large it complements. I mean, Eric, would you comment on that?
I'm not too sure if they're replacing them, but they're definitely a good addition to what we're having. It's a little bit, we have the same problem like Damian with Coca-Cola. We had a lot of silos. And also, like in the last presentation, a lot of these systems were built, a lot of these data storages were built for a specific system. There's a sales system, there's the sales information inside. What Hadoop is now us actually allowing, and this is the reason why I really like this term single source of truth. All of our systems are bring all these data into one single source of truth, so that basically that the decision makers have all these, and first of all, we could make sure that all have the correct information and they have all available information when to make their decisions. And in this regard, Hadoop helps us a lot.
Very good. Earlier, Sean was talking about data in motion, data at rest, Hadoop being a key component for that platform for data at rest. But I think in both cases, for both use cases, for both of you, there's data that's at the edge, data that you're bringing back in various ways. Can you talk a little bit about how you're bringing back data, whether it's streaming or batch, or however you're bringing data back into the platform? Maybe, Damien, we can start with you.
Okay, so when we set up Hadoop, we set it up in Azure. Basically, it's not an HD Insight. It's basically that we brought the VMs, and on top of that we put a HTTP. So we are using Hortonworks for that. Why we did that? It's basically that we wanted to have the flexibility to choose our own components and to install them and test them. So that's why we are testing. We are using Drill, Presto, etc., etc. And at the same time, when we set up that platform, we saw that if we just bring the data using flat files and it really it just defeat the purpose of having Hadoop. We need as well tools which are able to handle a huge load of data and enable us to plug basically in any and every system and extract the data and bring the data where we need to have them and after being able to process that data. And that's where we started to use NiFi. Basically, we started last year using NiFi. One aspect of NiFi which was really good is the side-to-side connection that you can set up, which enables you basically to connect several instances of NiFi together and stream data between them. And also, with JDBC and all the processors that you have already in NiFi. Some of them we had to improve, actually.
That's why it's open source. It's all good.
We have to revert back to open source, actually. And that's why we chose NiFi for big data and integration. We've seen that NiFi being quite early in terms of maturity, it has not all the connectors that you would require to connect to, for instance, ERP systems and things like that. So that's where we had to define a new policy where basically our ESB, our enterprise service bus, is the combination between NiFi and Boomi, which is another ESB that connects well with the ERP part. And we manage all the flows. Right now we have more than about 20 gigs, sorry, not terabytes, every day that we stream to Hadoop. We have more than 1,000 tables and containers in Hadoop of data, and we are already at 20 terabytes of data when we started basically last October. So yeah, it's going fast, very fast.
That's great. So it's an exact use case of similar architecture that Sean was describing of data in motion, data at rest,
exactly.
using those two technologies. Eric, what about you?
I will try to keep it a little bit shorter since we're running out of time. So I will explain this also because I have also tomorrow's speaker session, so I will explain this a little bit in detail. But in general, it's a typical Lambda architecture. We have a speed layer, a data layer, and a batch layer. The speed layer I also like to call the IoT layer. For this, we're using Apache Storm. Apache Storm is basically responsible for collecting all the truck data. Here's important to mention, there could be 3 different kinds of data streams coming from our truck. One is on a trigger base. If something specific is happening, it sends a specific data package to our backend. The other thing is like on a period, like for example, every minute it sends a specific set of sensors to our backend. And the other thing is like streaming data. Streaming data, they're not doing it on a constant basis, only on specific conditions. I will talk about that tomorrow a little bit more in details. But for that, Storm is responsible. It takes all these data coming directly from the trucks, deconstructing the messages, and then the important thing is moving these data to systems, persons who could really have direct use, creating benefits out of these data. For storing these data, we're mainly using HBase for the telemetry data. And for the batch layer, there we might mainly utilizing Spark. So we have all these source systems. They will have a data dump once per day into our data lake. And from there, Spark will take these data dumps and first do a data cleansing and validation, master data management, and then an aggregation, which then is used for analytics.
Right. No, very good. So let's kind of wrap up. I guess what I'd ask is, for the audience here, given that you both have, some way down your journey with Hadoop, what could you share with the audience in terms of insight and how you might recommend they start their journey? Eric, I'll start with you.
So for me, the most important thing is what I realized in this journey is you have to have the buy-in from your stakeholders. So for example, engineers tend to understand the benefits of data in their decision making. But normal business, sometimes I've encountered you coming to this business, they're doing their job since 20 years, and then you're saying, okay, I have here small software, it's doing your job better than you. This is not what you're telling them, but this is what they hear.
Right.
So you have to really tell them, it's not like replacing them or like replacing what they're doing. It's more like supporting them, giving all possible information and helping them in making these decisions. And for that, sometimes it's very good to start smaller. Just first go to the business and hear what are their pain points, what are the problems they wanted to solve. And sometimes there's a lot of quick wins, we like to call it quick wins. Just take one of these quick wins and just show the business how data could support them in their daily business and how we could solve their problems. As soon as they're building trust in you and in what you could offer, they will come with other problems to you they want to solve. And then it's basically where all this whole dynamic is starting, you're transforming to more a data-driven company.
Right, very good. Damien?
Basically, I would say the same thing as Eric, but I would just add one thing, which is, we have lots of discussion around analytics, predictive and prescriptive analytics as well. The problem with those messages is that basically those technology can do everything and tell you what will happen tomorrow. But in fact, it's not the case. Even the weather forecast, for instance, yesterday, the weather forecast was saying that it would not rain in Tokyo. And it actually rained yesterday night, right? So, you have to manage expectation as well from your business because they hear really crazy things from vendors saying that They can basically give me your data, and we can do everything you want. We can tell you if your market share will go up or down, or if you know, we will have an earthquake or something like that. But in fact, it's not necessarily the case. Depending on the granularity and where you want to be, of course, it can give you some insights, or it can give you some recommendation of what to do, etc. But it's not a magic trick that can tell you everything. And if it was, frankly, I would not be here. I would be, you know, already retired on an island, to be frank with you.
Good. So manage expectations
Yes.
in terms of what the technology can do, but also get buy-in from the key stakeholders and users, both kind of technical and business, in order to help get support and move the Hadoop implementation along, the big data implementation along. Very good. Well, with that, I'd like to thank both of our speakers, Damien, Eric. Thank you very much for the panel. Thank you very much. So I'll conclude the panel, and then let me just finish off this morning's session. So this concludes the end of this morning's session. Let me just give you a little bit about what you should expect for the rest of the day. So what you have is your guide for the sessions that will be going on today. In the guide, there are 2 tracks that will be delivered completely in Japanese, and we want to make sure you know those. The 2 center tracks are completely in Japanese, so if you want to go to those, you can go and listen to that content. And there are 2 tracks that which will have translation. So they'll be given in English, but we'll have Japanese translation. So you can choose which of the 2 tracks that you would like to go to today, this afternoon. Same will be true tomorrow. So in terms of the structure for the rest of the afternoon, sessions will begin right after this. We'll go into sessions from 2:10 until 3:40. So you go and choose and pick a couple of sessions. Then we'll have a nice afternoon tea break from 3:40 to 4:10. All of the sessions, let me say, are downstairs on the 3rd floor. You can either go down the elevator, or there are stairs off to the left as you go out the door down here. The afternoon tea will be in the community showcase in the room next door, where if you joined us for lunch, we had lunch. So please do go and share the insight, communicate, share with your partners, share with your coworkers, share with the other attendees that we have here at the event today. Then after that, we'll have more sessions from 4:10 till 6:30, again, downstairs on the 3rd floor. And then at 6:30, from 6:30 till 7:30, we'll have a reception in the sponsor area. We'll have some drinks, some food. Please come again, share what you learned from the afternoon, exchange ideas, speak with our sponsors, learn about the kinds of solutions that they have. So I'll say, again, remember to keep social. I understand now that we're trending number 3 in terms of our hashtag, so you're doing very well, so please keep it up. Thank you again for coming today, and this concludes our sessions. Thank you very much.